have now on. Mating systems are fundamental to behavioural ecology. And we're going to go over in this lecture 4 critical papers, well, three really critical papers and 1 interesting review synthesis. 3 milestone papers that you really, really need to know about. And they are Bateman, 48, Trivers, 72, and Emlen and Oring, 77. Those are kind of a backbone of our thinking about mating systems right now. And then Coco et al. Here is a recent review and synthesis and are pointing out that it's not quite as simple as it seems, and quite a good kind of overview of all of these topics. So we'll begin with Bateman. And you'll meet Bateman because he has a principle, the Bateman principle. Oh my goodness, what is going on here? I'll just... Something is going fishy. Right. Okay. I think what's happened is it's blanket increased the font size all over the place. There we go. That's what we want. So the Bateman principle, you'll meet the Bateman principle and the Bateman gradient in the literature. And the Bateman principle is that female fitness tends to be limited by the number of eggs they can physically produce, whereas. And that is because they invest more in their eggs than males. Whereas male fitness tends to be limited not by the number of sperm they can produce, because they produce billions. A male is typically not limited by the number of sperm, but by the number of mates he can physically find and mate with. Okay, so females are limited by eggs, and therefore the resources they can gather in order to produce those eggs. And males are limited by mates, so by competition for mates and by mating effort. And this is illustrated by Bateman's experiments in fruit flies. That principle has its roots in anisogamy, the difference in investment in sperm versus large numbers of sperm versus small numbers of eggs. For goodness sake. So try and navigate yourself around this text here. But Bateman discovered or found in his population of mating fruit flies, he managed to track the offspring of labelled lines of males using kind of radio labels, isotopes. And it's way before we were able to assign offspring genetically. And what he found was that the more mates he allowed individuals to have on the x-axis, the more offspring they had, obviously, but the shape of that curve was different in males versus females. Beyond an initial, obviously, if you don't have any mates, you can't have any offspring. But after the first one, female offspring tended to be relatively flat. As females have more and more mates, they tend not to have more offspring. They just have pretty much the same amount of offspring, regardless of how many mates they've had. But males, that wasn't the case. The more mates the males had, the more offspring they tended to father. And so Bateman's reasoning here is that the gradient of this line is steeper for males than it is for females. So a male has more to gain by seeking additional mates than beyond the first one than a female does. And so that gradient, the gradient of offspring upon mates, is higher for males than females. And what that gives you is a situation where females, which are in white here, tend to have a frequency of numbers of offspring which is very tight. Like the variance in the number of offspring that a female leaves behind, or number of mates for a female, tends to be much less. Females tend to have only a few mates in their lifetime, whereas males are much more variable. If you look at this histogram, what this is telling you is that females all tend to have the same number of mates, whereas a few males have shitloads of mates, and a few males at the other side have no mates at all. There's much higher variance in male mating success, and therefore much higher variance in male reproductive success than females. So some males are superstars, and some males are complete losers, whereas females all tend to have similar amounts of offspring. That is the Bateman principle. That has very, very high, a lot of knock-on effects, because the more variance you have in mating success, the more opportunity there is for sexual selection, as we will see. This Bateman principle then leads to something called Fisher's equality constraint. So onto this, you just add the concept that males and females, on average, absolutely have to, it is mathematically certain that males and females must, on average, have the same reproductive success, on average. And that is because it takes, there's a beautiful paper about this called It Takes Two to Tango. And every individual, you know, an ant, maybe ant is a bad example. Every diploid organism has exactly one mother and one father, and was the result of one mating which took place between one mother and one father. So, on average, male and female reproductive success must be exactly equal. There is no such thing as males being more successful than females on average. So if you get superstar successful males, they have to occur alongside unsuccessful males. Oh, for goodness sake. Within the sex, within males and within females, reproduction is basically a zero-sum game. Successful males are basically taking reproduction away from successful females. So if that is the average number of offspring for females there, then those males at the top there, the males that are superstars and getting loads of matings, are effectively stealing offspring from the males at the bottom who are getting no mates. Yeah, does that make sense? Because every mating takes one male and one female exactly. Good. Beans on that, because this is an important principle, especially when we're talking about parental care. A nice example of this is in wolf spiders, like a kind of a demonstration of this in wolf spiders happened where, you know, with Norton and Uwitz, they found in nature that 93% of their females that they studied only chose, when given the chance to mate multiple times, they rejected males after the first mating. So 93% of the females chose to mate only once. Whereas males tended to mate with anyone that they put them with. So males were much keener for multiple matings than females were. There have been problems and criticisms of that original study by Bateman. So the methods he used to track offspring have now been superseded by, you know, genetic methods. Bateman couldn't track every single one of the offspring. This Patricia Gowerty has been leading the charge to replicate and critique this fundamental study that's cited so many times, and she has been unable to replicate his original results, which is very interesting and definitely worth a look. But it should also be pointed out that still, like nowadays, we don't really have much of an issue with the findings here. There are complications and codas and caveats that kind of may alter the direction of sexual selection, but fundamentally this product of anisogamy is something that we don't really, this is still current thinking. Anisogamy leads to a situation where males tend to get more offspring from more mates than females. We will come back to it because there are definitely codas and caveats to add to it. But that's the Bateman principle. Now we're going to move on to Bob Trivers, who formulated on the basis of Bateman. Bob Trivers took it a bit further and in 1972 produced a paper called Parental Investment and Sexual Selection. Trivers' point